The Stratolaunch Roc is a massive, uniquely designed dual-fuselage carrier aircraft developed by Stratolaunch Systems Corporation to air-launch rockets and other vehicles to high altitudes. It features the longest wingspan of any aircraft at 117 meters, surpassing even the famous Hughes H-4 Hercules Spruce Goose. The Roc's design incorporates two fuselages/cockpits mated to a single wing, powered by 6 Pratt & Whitney PW4056 turbofan engines originally designed for the Boeing 747. It has an immense maximum takeoff weight of 590,000 kilograms and is designed to carry payloads of up to 250,000 kilograms between the two fuselages. The primary purpose of the Stratolaunch Roc is to carry rocket-powered vehicles to around 10,700 meters and release them for air launch to orbit. This air launch capability allows rockets to avoid the dense lower atmosphere, saving substantial fuel compared to vertical ground launches. It was originally intended for launching orbital-class rockets, but after a change of ownership, its mission shifted to air-launching hypersonic research vehicles. The Roc was developed over 8 years at the Mojave Air and Spaceport at a cost exceeding $1 billion by Stratolaunch, a company founded by the late billionaire Paul G. Allen. Its first test flight occurred in April 2019, shortly after Allen's passing. The company is now owned by Cerberus Capital Management. In March 2024, Stratolaunch successfully conducted the first rocket-powered test flight of its Talon A-1 hypersonic research vehicle, launched from the Roc aircraft. The massive size allows the Roc to serve as a unique air launch platform for testing hypersonic flight and potentially future spaceplanes or reusable spacecraft from its center wing pylon. The name Roc draws inspiration from the mythological giant bird of Middle Eastern folklore capable of carrying off elephants, reflecting the aircraft's formidable size and strength. It represents a pioneering achievement in aviation, pushing the boundaries of aircraft design and operational capabilities. Let's delve into the fascinating world of the Hillers Air Tug, an ambitious concept from the 1960s that aimed to catch rockets midair using an enormous helicopter. The Hillers Air Tug was no ordinary helicopter. It was a behemoth with a rotor diameter exceeding 400 feet, around 120 meters. Imagine a rotor span larger than a football field. This massive aircraft had a unique purpose: to play catch with a moon rocket, specifically the Saturn V's first stage. The Air Tug wasn't technically a helicopter. It was a rotary wing system for booster recovery. However, it looked and operated like a helicopter, earning it the nickname Air Tug. Its rotor system featured jet engines on the tips, allowing the rotors to complete 1 rotation per second, an impressive feat for something so wide. The engine was situated vertically within the rotor stem, and the Air Tug had 2 curving sides to stabilize rockets during flight. With a weight of 450,000 pounds, around 200,000 kilograms, it could carry a payload of 550,000 pounds, about 250,000 kilograms, resulting in a total gross weight of 1 million pounds. When a rocket, specifically the S-1C booster, was launched, the Air Tug would take off from a nearby airbase. It would fly to the designated landing zone where the booster was expected to descend, hovering at an altitude of 15,000 to 20,000 feet, 4,500 to 6,000 meters. The Air Tug would wait for the booster to separate from the upper stages. The booster would deploy a double tandem parachute, with the upper section featuring a hook. As the rocket descended, the Air Tug would meet it at around 10,000 feet, 3,000 meters. The daring maneuver involved hooking the descending rocket mid-flight, effectively catching it like a giant tugboat catching a falling object. The physics behind this operation were complex. The Air Tug had to match the rocket's descent rate, position itself correctly, and engage the hook, all while dealing with aerodynamic forces and rotor dynamics. Unfortunately, the Hillers Air Tug remained a concept. It was never built or tested in real life. However, the idea of reusing rockets and catching them midair has resurfaced more recently, with companies like Rocket Lab exploring similar concepts. Airbus Beluga XL. It's probably the strangest named plane ever built, but once you see the Airbus Beluga XL, it becomes immediately clear why it's said to look so similar to the species of whale. Designed to be a new style of heavy transport aircraft fit for modern times, it was first revealed by Airbus in 2018 and entered service for Airbus Transport in 2020. Based on a previous smaller design, there are currently 5 of these aircraft in operation, with a further one expected to be ready by 2023. Airbus is mainly using them to move airplane parts between the different factories. The Beluga XL is unique in that it's been specifically designed to be able to transport two A350 XWB wings at the same time. To do this, the 270-foot-long plane has a wingspan measuring just under 198 feet and has a cargo hold with a volume of 78,000 cubic feet. The two Rolls-Royce Trent 700 turbofan engines, which each produce 71,000 pounds of thrust, mean that it can carry loads that weigh up to 56 tons, while maintaining a cruising speed of 458 miles per hour, with a range of 2,600 miles when fully loaded. It's definitely one of the more unusual planes you'll ever see in the sky. Based on the success of the Beluga XL, it could well be a design that becomes increasingly more common in the coming years. Boeing 747 Dreamlifter. While Boeing 747-400 and 747-8 are aimed at cargo customers looking to transport goods around the world, the biggest capacity aircraft that's built by the company is actually another variant called the 747 Dreamlifter, and it was specifically designed for use by Boeing itself. With 3 times the capacity of a 747-400, only 4 have ever been built since being introduced in 2007, and they're all used mainly for one specific purpose: to transport components for the 787 Dreamliner from worldwide suppliers. Traditionally, aircraft parts would also have been delivered by sea, because it's far cheaper to do so. But it also takes a significant amount of time for the parts to arrive. Boeing needed to keep up with a large number of orders. The Dreamlifter is an adapted 747, which has a main cargo compartment with a volume of over 65,000 feet and a max weight capacity of 125 tons. It's a few feet longer than a passenger 747, at 235 feet wide, but has the same wings with a span of 211 feet. Speed and range has, however, been sacrificed to enable the transportation of heavy, bulky loads. So with its 4 PW4062 engines, it's able to reach a cruising speed of 545 miles an hour, over a distance of up to 4,800 miles. Let's explore the colossal Mi-32, a remarkable Russian helicopter that once captured the imagination of aviation enthusiasts. Mi-32, a super heavy transport helicopter in the 1970s, the Soviet Union faced a unique challenge. The fuel, energy, and raw material resources were shifting from the European USSR to the vast regions of Siberia, the extreme north, and the Far East. These remote areas posed enormous distances, complex terrain, severe climates, and a lack of roads and airfields. Helicopters played a crucial role in ensuring a steady supply of industrial equipment and goods to these regions, regardless of the season. However, existing helicopters like the Mi-6 and Mi-10K couldn't always meet the demands of transporting heavy machinery and construction equipment, which sometimes weighed 35 to 40 tons. The armed forces also needed helicopters capable of transferring large combat technology, including tanks, rocket installations, and engineering equipment. In the mid-1970s, the Soviet government tasked MIL, the Design Bureau, and TSAGI, Central Institute of Aero Hydrodynamics, with studying the feasibility of transporting heavy loads using multiple helicopters connected by a rigid frame. The idea was to create a super heavy transport helicopter capable of carrying massive payloads. MIL explored various options, including using 2 or 3 Mi-26 helicopters with a common cable suspension. Additionally, they considered a 2 or 3 screw helicopter based on the Mi-26 system. The result? The ambitious project received the designation Mi-32. Rather than opting for a single rotor design, which would complicate the main rotor gearbox and carrier system, MIL drew inspiration from their experience with the V-12 helicopter. The V-12 had doubled carrier systems from a single rotor helicopter, allowing it to handle increased load capacity. Following this approach, the Mi-32 utilized carrier systems and power plants from the Mi-26, a proven heavy lift helicopter. The Mi-32 aimed to be a workhorse for transporting heavy machinery, combat vehicles, and other oversized cargo. The Mi-32 was designed to carry exceptionally heavy loads, far beyond what existing helicopters could manage. It could transport industrial equipment, combat technology, and even evacuate damaged vehicles. The development of this unprecedented machine was conducted with great enthusiasm, but technical challenges remained. Unfortunately, the Mi-32 remained a concept. It was never built or tested in real real life. The Mi-32 represents an audacious vision, an attempt to conquer the skies with a helicopter capable of lifting immense loads. While it never took flight, its legacy lives on as a testament to human ingenuity. The incredible Boeing B-52 Stratofortress was developed by the company in the 1950s for the U.S. Air Force, and between 1952 and 1962, 744 of the long-range strategic bombers were built. It was an absolute game-changer for the Air Force's capabilities, offering the ability to carry 35 tons worth of ordnance with a range of 8,800 miles before it needs to refuel. The main intent of the plane was to be able to carry nuclear bombs during the Cold War. Well, they have, of course, only ever been used to drop conventional bombs. At 159 feet long and a wingspan of 185 feet, the Stratofortress requires a 5-member crew to operate fully, which includes a pilot, co-pilot, a weapons systems officer, a navigator, and an electronic warfare officer. It weighs more than 132 tons on its own before any cargo was loaded. To make it airworthy, it's fitted with 8 Pratt & Whitney TF-33 turbofan engines that produce 17,000 pounds of thrust each. Flying at an altitude of up to 50,000 feet, it has a cruising speed of 509 miles per hour, or a top speed of 650 miles per hour if needed. As well as the bombs it carries, which can be a range of different options, B-52s could originally protect themselves with an M61 Vulcan cannon in the tail turret, although these were all removed in 1991. The Antonov An-225 Mriya, which translates to dream in Ukrainian, was a legendary Soviet/Ukrainian strategic airlift cargo aircraft and an icon of aviation, designed and produced by the Antonov Design Bureau in the Soviet Union during the 1980s. It made its maiden flight on December 21, 1988. The An-225 was originally developed as an enlarged derivative of the An-124 to transport the Buran spacecraft orbiter for the Soviet space shuttle program. With a maximum takeoff weight of 640 tons, a wingspan of 88.4 meters, wider than an Airbus A380's 80 meters, and powered by 6 turbofan engines, the colossal An-225 was the largest and heaviest aircraft ever built. It had a 32-wheel landing gear and could carry a maximum payload of 250 tons, setting the world record for air cargo transportation with 189.9 tons in a single flight. The unique aircraft garnered over 200 world records during its 30-plus years of service. After the dissolution of the Soviet Union, the one-of-a-kind An-225 became part of Ukraine's Antonov Airlines fleet for commercial operations based at Hostomel Airport near Kiev. Despite plans for a second airframe, a lack of funding prevented its completion. The Mriya did not fly for a year after the Soviet collapse, but returned to the skies in 2001 with a test flight. Tragically, the sole existing An-225 was destroyed in February 2022 during the Battle of Antonov Airport in the early stages of Russia's invasion of Ukraine. Its destruction represented a major blow, as the aircraft's unmatched air freight abilities were lost forever. Nonetheless, the legendary Mriya left an indelible legacy as a testament to Soviet engineering and aviation prowess. The Super Guppy, designed by Aero Spacelines, is a huge cargo transportation plane that first took to the skies in 1965. Only 5 were ever built, but they were made for the requirements of one client in particular, NASA. They were and remain the only aircraft ever built that's able to transport a complete S-4B stage, which is the 3rd stage of a Saturn V rocket, and the Super Guppies were vital to enable NASA to launch missions to the moon. At 143 feet long and with a wingspan measuring 156 feet, the Super Guppy has 4 Allison 501 turboprop engines that power the 4 propellers. Requiring a crew of 4 to operate, it has a cruising speed of 250 miles per hour, with a maximum range of about 2,000 miles when fully loaded, with up to 26 tons. Even though the Apollo program has long been canceled in favor of more efficient alternatives, one of the Super Guppies is still used by NASA to transport components between facilities. The others can now be seen on display around the world, both because of their unique design and because of their place in spaceflight history.